In this lesson, we're going to be focusing on calculations on even, odd, and other functions. So for each of the questions we're going to be solving, we're going to determine if it is an even function, odd function, or another function. Now, for a function to be an even function, f of negative x must equal f of x. Then this is for even function. Then for odd function, f of negative x must equal negative f of x. So for each of these functions, we're going to be replacing x with negative x and then solve and know if we're going to get back the original function, which is f of x, or negative original function, which is negative f of x. So let's start with this question. We have f of x is equals to x sin x. So the first thing we're going to do is to replace x with negative x. Then replace this x with negative x. Then multiply by sine of negative x. So we have f of negative x is equals to negative x. Now sin x in itself is an odd function. So the sine of negative x is going to return negative sin x. Alright. So we have that f of negative x is equals to minus times minus is plus. So we have x sin x. So we have that f of negative x is equals to, now this x and x is equals to the original function we have, which is f of x. So with that, we say that this is an even function. So let's solve another example. As we have f of x is equals to cos x plus x raised to the power 4. So let's replace x with negative x. So we have cos negative x plus negative x raised to the power 4. Then we have f of negative x is equals to, now cos in itself is an even function, so cos of negative x is going to be equals to cos x. Then we have plus negative x raised to the power 4 is equals to x raised to the power 4. So we have that f of negative x is equals to cos x plus x raised to the power 4, which is equals to the same function we have, f of x. So in turn, this is also an even function. So as mean you have f of x is equals to x raised to the power 3 plus x square. We have to determine if this function is even or odd or neither. Then we have f of negative x is equals to negative x raised to the power 3 plus negative x raised to the power 2. So f of negative x is equals to, now negative x raised to the power 3 is still equals to negative x raised to the power 3. Then we have plus negative x square is equals to x square. So we have that f of negative x is equals to, now we have negative x cube plus x square. What we have here is x cube plus x square. There's no way we can rearrange this expression here to be equal to this x square plus x cube. So we are going to say that this function is another function because f of negative x is not equals to f of x or negative f of x. So this function is another function. It's not even, it's not odd. Another example is f of x is equals to absolute value of x. So this function, even function, odd function, another function. So we're going to replace x with negative x equals to this, we have negative x. So we have that f of negative x is equals to, now absolute value function is an even function. So any negative value inside an absolute value function is going to return a positive answer. So negative x here is going to return the value of x. Alright. So with this, we say that f of negative x is equals to f of x, which is the original function. So we say that this function is an even function. So let's solve this one. We're given f of x is equals to x raised to the power 3 plus x. So I have f of negative x is equals to negative x raised to the power 3 plus negative x. So you have that f of negative x is equals to negative x raised to the power 3 is still equals to negative x raised to the power 3. Then plus times minus is minus x. So you have that f of negative x is equals to, let's factor out negative here. So you have minus, then we are going to change the signs. This one will be s cubed then plus x. So you have that f of negative x is equals to minus, now s cubed plus x is what we have here in the original equation. So this is going to be equals to negative f of x. Alright, so because this f of negative x is equals to negative f of x, which is what we have here, then this function is an odd function. Alright, so let's take a look at some graphs of even function, odd functions, or neither functions. So let's take a look at a graph of f of x is equals to s squared, and this is going to be a pure sketch, so it's not drawn to scale. It is just a representation of the graph. So f of x squared is a graph that looks like this. Sorry for that. So it's a graph that looks this way. So for an even function, the graph is symmetrical about the y-axis. So look at what I mean. This part of this graph is equals to this part of this graph. So if you fold this graph, this part and this part are going to lap, right? They are going to join. So this is how to know a graph of an even function. So let's take a look at a graph of an absolute value function, which is equals to absolute value of x. So the graph of this function looks this way. That's the parent function of this absolute value, looks this way. So as you can see, this right hand part of this graph is equals to this part, and if you fold this graph, this part and this part are going to join, right? So they're symmetrical about the y-axis. So it means that this part is equals to this part. So let's take a look at another graph, which is a graph of cosine function. So f of x is equals to cosine of x. So this function, again, this is a sketch. So this function behaves this way, right? So this is how the function behaves. So if you look at this, you see that this part of this graph is equals to this part of this graph, right? That's symmetrical about this y-axis. So if you fold this graph, this and this are going to lap together or join together. So that's how to know a graph that's an even function. So let's look at graphs that are odd function. So let's look at graph of y is equals to sq. Alright, so in this graph of y equals to sq, this graph behaves this way. Alright, so if you take a look at this, you see that this part of this graph is equals to this part of this graph. So we say that it's symmetric about the origin. Alright, where this part must be equals to this part, or this part must be equals to this part. So that's how to know a graph that's an odd function. So let's look at a graph of sine x, right? Graph of sine x. So sine x is an odd function. So how is the graph? So the graph looks like this. So the graph looks like this. If you look at this graph, you see that this part of this graph and this part of this graph are the same. Okay, so this is how to know a graph of an odd function. So for you to know the graph of the one that's not even or odd, so the graph must not be symmetrical about the y-axis or symmetrical about the origin, like this odd function. So this is all about even, odd, and other functions. Thank you for watching. Please remember to subscribe to my YouTube channel, turn on the post notification bell so that each time I post a new video, you'll be the first to watch it. See you in my next video.